Pluto was once considered the ninth planet of our solar system, but in 2006, the International Astronomical Union or IAU reclassified it as a dwarf planet. This decision was based on several factors including its size, orbit, and composition. First being Pluto's size. Pluto's size is much smaller than the other 8 planets in our solar system. It is only two-thirds the size of Earth's moon and much smaller than other gas giants like Jupiter, Saturn, Uranus, and Neptune. Its small size means that it does not have enough gravity to clear its orbit of other debris, unlike the other planets. Secondly, Pluto's orbit is highly elliptical, meaning that it is not in a perfect circle like the other planets. It also crosses the orbit of Neptune, which further complicates its classification. Its unusual orbit makes it difficult to categorize it as a planet or a member of another class of celestial bodies. Finally, Pluto's composition is different from that of other planets. It is made up of rock and ice, whereas the other planets are primarily made up of gas and dust. This difference in composition further supports the idea that Pluto is not a true planet. In conclusion, the reclassification of Pluto was based on several factors, including its size, orbit, and composition. While it was once considered the ninth planet in our solar system, it is now recognized as a dwarf planet. While this decision was controversial, it was made based on scientific evidence and the need for a clear definition of what constitutes as a planet. Pluto was discovered in 1930 by the American astronomer Clyde Tombaugh and was considered the ninth planet in our solar system up until 2006, when it was reclassified as a dwarf planet. Pluto has a unique surface that is unlike any other object in our solar system. The surface of Pluto is covered in a layer of frozen nitrogen, methane, and carbon monoxide. These ices give the planet a distinctive reddish-brown color. The surface is also marked by a variety of geological features, including mountains, valleys, and plains. One of the most striking features on Pluto's surface is a large heart-shaped region that is known as Tombaugh Regio. This feature is about the size of Texas and is made up of a bright icy plain that is surrounded by rugged mountainous terrain. The mountains in this region are believed to be made of water ice, while the plains are composed of a mixture of nitrogen, methane, and carbon monoxide ices. Another notable feature on Pluto's surface is a series of deep canyons that are similar in appearance to those found on Mars. These canyons are up to 6 miles deep and are believed to have formed as a result of tectonic activity on the planet's surface. Pluto's surface also shows evidence of past and current geological activity. For example, scientists have observed evidence of cryovolcanism or the eruption of icy materials from the planet's interior. This activity is thought to be driven by the heat generated by the decay of radioactive elements in Pluto's core. The surface of Pluto is fascinating and complex landscape that is unlike anything else in our solar system. Its icy plains, rugged mountains, and deep canyons provide clues about the planet's geological history and the processes that have shaped its surface over time. Though continued study and exploration, scientists hope to learn even more about this distant and enigmatic world. One of the most intriguing aspects of Pluto is its system of moons, which includes 5 known objects. Even though Pluto was discovered in 1930 by the astronomer Clyde Tombaugh, but it wasn't until 1978 that its first moon, Charon, was discovered. The discovery was made by astronomer James Christie, who noticed a bulge on one side of Pluto's disk during observations. Upon further investigation, he realized that he had discovered a moon orbiting Pluto. In the years that followed, 3 more moons were discovered: Nix and Hydra in the year 2005, and Kerberos in the year 2011. The fifth and final moon, Styx, was discovered in the year 2012. These discoveries were made possible by the advances in technology, including telescopes and cameras that allowed scientists to observe Pluto and its surroundings. Pluto's largest moon, Charon, is the most well known of its moons. It is approximately half the size of Pluto and is so large in comparison to its host body that some scientists argue that Pluto and Charon should be considered a double planet system. Charon's surface is heavily cratered and has a range of mountains and valleys. Nix and Hydra, the second and the third largest moons, are irregularly shaped and have a highly reflective surface. They are believed to be composed of mixture of rock and ice. Kerberos and Styx, the smallest of Pluto's moons, are also irregularly shaped and have a dark reddish surface. The discovery of Pluto's moons has provided scientists with valuable insights into the dwarf planet and the early solar system. For example, the fact that Pluto has multiple moons suggests that it may have formed from collision between two objects, similar to how Earth's moon is believed to have formed. Additionally, the composition and characteristics of Pluto's moon can tell us about the conditions in the early solar system. For example, the highly reflective surfaces on Nix and Hydra suggest that they are composed of water and ice, which may have been common in the early solar system. Pluto's moons are a fascinating and important area of study for astronomers and planetary scientists. Their discovery has provided valuable insights into the dwarf planet and the early solar system, and continued research may reveal even more about the history and evolution of our cosmic neighborhood. As we continue to explore and learn more about Pluto and its moons, we are sure to uncover new and exciting discoveries that will expand our understanding of the universe. Pluto orbits the Sun in a distant region of our solar system known as the Kuiper Belt. Its orbit is highly elliptical, meaning that it is not perfectly circular, but instead has a stretched out shape. Pluto takes approximately 248 Earth years to complete one orbit around the Sun. Pluto's orbit is also tilted relative to the plane of the solar system, which means that it does not follow the same path as the 8 planets in our solar system. Instead, its orbit is inclined at an angle of 17 degrees to the ecliptic, which is the plane of the solar system. This tilt causes Pluto to move above and below the plane of the solar system as it orbits the Sun. Pluto's orbit is also unique because it is not a clean sweep of its orbit. In other words, it has not cleared its orbit of other debris and objects. This is one of the reasons why Pluto was reclassified from planet to a dwarf planet in 2006. However, Pluto still has a system of moons that orbit it, and these moons follow their own orbits around Pluto. Pluto's orbit is affected by the gravitational pull of other objects in the Kuiper Belt, as well as by the gravitational pull of the Sun. This can cause Pluto's orbit to change slightly over time, which can affect its position and speed in space. Because Pluto is so far away from Earth, it is difficult to observe and study its orbit in detail. However, through the use of telescopes and other instruments, scientists are able to track its movement and learn more about its orbit and the conditions in the Kuiper Belt.